Hello, and this time we're looking at substitution, algebraic substitution, where we're replacing in an expression where we have some letter or maybe several letters. We're going to replace those letters with numbers that are given. And the point about these algebraic expressions is that these values of p, q, and r could be anything. That's why we've written it with algebra, but we don't know what it is. Or it might be that we're saying there's a relationship between these things. So like if you know that that doesn't look like a V, that voltage is the current times the resistance, that's a relationship that exists between these three variables. So if you change one of them, it will change the other values. And so when we're substituting things in, we're saying we have this one specific value where we decide the current is such, and we say, and we have a resistance of such, well, what would the voltage be in that situation? And that's just what we're doing here, but rather than doing formulae and substituting and finding a value from in a formula, we're just doing it with expressions here, so it's slightly easier, and we're working out what is the value of this expression. Well, we don't know because we don't know what p is, but if we are told what p is, then we can put that in and find out what it is. And this substitution, it's very much just a case of swapping them out. So instead of having p, we're going to swap it for 4. Because they are equal, we can just swap them out without any concern at all. Just one more thing before we start doing the examples. When you've got things like 3p or pq, remember this means 3 times p and p times q. Okay, so when you substitute them in, when we put 4 in, it's not going to be 3 4 is 34 plus 7. We have to put the times in, yes, which was omitted from saying 3p. It's just because we times so much together, it's just a little shorthand just to sort of omit the times symbol, make it look neater. That's what we do. But when we put the numbers back in, we do have to put times so that people don't think it says 34. So you just got to remember that that is the times, and we need to put the times in when we do it. Okay, we also need to follow BIDMAS when we've substituted things in, so we have to get the order right, so doing the times and then the add, and if there's powers involved, do the power, then do the divide. Okay, now let's just go through these 8 examples and see what we get. So A, we're going to say it's not writing. Having a little crash is PowerPoint, so just bear with. I'm sure it will come back any moment. There we go. Right, so 3p is 3 times 4. So replacing it with the 4 plus 7. And we can just work this out. 3 times 4 is 12 plus the 7 equals 19. Part B says p times q. I don't know what either of these are, but they are given as 4 and minus 2, so it's going to be 4 times minus 2. I just replace the p with the 4, the q with the minus 2, and the answer is minus 8. And just work it out. And if you're not sure about that maths, well then you just get your calculator and you just type it in, like the first one, 3 times 4 plus 7, and press equals, and it tells you 19, and the second one, 4 times minus 2. There you go. So that bit numeracy you can actually do on the calculator. If you've shown the substitution, then the examiner will see you know how to substitute, and it's perfectly legitimate to then just get the numerical answer like that if you need to. Okay, now be careful with this one, because q squared, if we replace q with minus 2, it's minus 2 squared. Now, be careful, because this was the number q squared. So it's not 2 squared and a minus number, it is the number minus 2 squared. So I'm going to put a little bracket in. If you don't, even on a calculator, look, if we go minus 2 squared, it incorrectly tells us minus 4. We actually correctly tells us minus 4 because it's going to do the squared first, then the minus. But we want the number minus 2 squared, which squares the minus sign as well, which is positive 4. So just be careful with minus signs like that. Whenever there's a minus sign, I always put the number in a bracket. Okay, so for example, part A, sometimes I'll write it as 3 bracket and put the number I'm substituting in, and then plus 7. And that still means 3 times that number plus 7, but then if there was a minus, I'm not going to forget about the minus sign when I'm doing it, or, you know, make that square go wrong. Okay, and moving on, 2q minus r is 2 bracket minus 2. There's my bracket because I don't like the minus signs messing things up. And then minus bracket minus 3. Again, I don't want to lose track of those minuses. There's a negative sign for take away and a negative sign for the minus 3. The number is negative and we've got the take away. So I need both of them. So just be careful. 2 times minus 2 is minus 4. Take away minus 3 is plus 3. So that gives us an answer of minus 1. Okay, and if I do this on my calculator, then I'm going to do exactly the same thing. I'm going to go to bracket so that I know my calculator isn't going to misinterpret my minus signs, and then minus r in a bracket minus 3. And using brackets like that means, no mistakes made. It gets the same as me. I'm happy. 2 times 4, I'm just going to put them all in brackets so that I don't make a mess of these minus signs, and minus 3. Well, this is nice because minus and minus are going to give me positive, and then I can just work out 2 2s are 4, 4 times 4 is 16, and 3 16s are 48. R cubed is minus 3 cubed. 3 minus signs times together is still minus, and 3 times 3 times 3 is 27. Q times R is minus 2 times minus 3, okay, and then over 4, I'm not going to put that in a bracket because it's not being times by anything. Minus and minus is positive, 2 times 3 is 6 over 4. I may as well simplify that down and say it's, what is it actually? 3 over 2. Divide them both by 2. And finally, the last example, p squared. I'm not going to use a bracket because it's a positive number, so I don't need a bracket this time. 4 squared over, and q, I don't need a bracket because it's not doing anything. That minus sign, we don't like to leave that on the bottom, so you either put the minus sign in front of the fraction, so it would be minus 16 over 2, or you put it on the top of the fraction, so you could write it as minus 16 over 2. That minus sign can just move around. It's absolutely fine. We don't generally leave it on the bottom. Okay, but of course 16 over 2, we can get rid of that anyway and just get a nice answer of 8. So we didn't need to worry about that in any case. So those are just a few examples of substituting. Watch out for those minus signs and make sure you do BIDMAS in the right order. If you use brackets, then you can type it into your calculator quite well. And if you have this kind of calculator with a calc button, you can actually write it in. Although I don't have P, Q, and R, I could write in, which one should I write in? Oh, I lost it. Let's do D. I could write it in like this, 2 alpha B minus alpha C, okay, where Q is B, so I was doing A, B, and C. So then if you press calc instead of equals, it'll say, what is B? And you can say, oh, well, that's minus 2. And it's, well, what's C? And I can't remember, minus 3, so you tell it it's minus 3, and then press equals again, and it will work it out. It will actually do the substitution as well. And that's really good function if you're doing lots of calculations where if you've got to do the exact same formula, but for sort of 10, 11, 12 things or more, then you can just type it in once, and then you just press calc, and it says, well, now what's B? Oh, well, this time B is 5, well, this time, okay? Likewise, you can use the store function. Let's say for these questions, P, Q, and R are always the same, which they are. Then you can do it like this. You can say 4, no, hang on, get rid of that. 4 store as A. You see you get this little arrow, say A has become 4, or 4 has gone into A. Minus 2 store as B. Whoa, not 4 minus 2, hang on. Minus 2 store as B, press AC. Minus 3 store as C, and now A, B, and C are set as these three numbers. So if I write in 3 alpha A plus 7, it works it out. If I write alpha B, alpha C, it just works it out because it's using the stored values. So likewise, if you have the same numbers with lots of different formulae and you haven't to substitute the same numbers in like this, using the store function is really, really good. No good in an exam, of course, because if you don't show that, then you're not going to get any marks. And of course, in an exam, you're not like to have 8 repetitions of an example. You're going to have 1 example anyway, so no point. But if, for some activity or in science or, day-to-day life, you just need to run the same numbers through many different calculations, or maybe you've got a mathematical constant that you need to use, or a scientific constant that you need to use again and again and again, well, then you can store it and then just press alpha B or whatever letter you've used to recall that number rather than having to type it in all the time. Right, I shall leave it there as I've rambled on quite a bit. If you have any questions, then you can pop them into the comments, but otherwise, cheerio for now.